Owning Bitcoin means owning a private key. In hardware wallets, that key is derived from a 12-word seed phrase. If you have those words, you control the assets on the blockchain. This chart compares 1 billion guesses per second against the lifespan of the universe. A seed phrase contains 128 bits of entropy, randomness so mathematically dense that even a supercomputer would run out of time before guessing the specific combination. The cold card wallet, built by CoinKite, was designed to be the peak of this security model. It is an air-gapped device, meaning it generates and stores these keys while physically disconnected from the internet. When a private key is generated offline and protected by these probabilities, the laws of physics and mathematics should make the funds untouchable. In August 2026, that mathematical certainty evaporated. Attackers drained 1,600 Bitcoin, roughly $100 million, from over 7,000 cold card wallets simultaneously. The attackers bypassed standard vectors like malware and phishing. Instead of a door being forced open, the heist functioned like a solid steel vault door that simply dissolved. The ultimate fortress had failed without a single password being stolen. The hackers had found a way to bypass the underlying math itself. A hardware wallet has one primary job: harvesting unpredictable randomness from the physical environment to build a unique seed phrase. The cold card ran on MicroPython firmware, which included a basic, weak random number generator. CoinKite developers knew this wasn't secure enough for Bitcoin, so they wrote their own advanced generator into the code. To ensure the device only used the secure version, the developers set a specific code flag to 0, which was intended to disable the weak MicroPython generator. The system used a check to see if the custom generator was defined. In this coding language, a 0 is often treated as a falsie or null value. Because the flag was 0, the check treated the 0 as a blank space, skipped the advanced generator, and defaulted back to the weak one. For 5 years, this high-security device was secretly running on a basic randomizer. Neither the creators nor the users realized the custom security layer was inactive. Without a standard operating system, a bare metal chip has no background activity, or noise, to use as a source for randomness. Because the active generator had no external data to draw from, it defaulted to faking randomness by using the device's own serial number and an internal timer. Serial numbers and timers are deterministic. They follow a predictable set path. By relying on them, the device removed the mathematical protection provided by entropy. The attackers didn't have to guess combinations out of the entire universe. They just mapped out the limited pool of serial numbers and clock values to reverse engineer the exact seed phrases. The hackers didn't break the cryptography. They just realized the infinite range of possibilities had been compressed into a predictable list. Bitcoin keys cannot be patched or rotated. Once the vulnerability was exposed, the only way to save remaining funds was to generate a new wallet and manually transfer the coins. Every transfer must first sit in the mempool, a public waiting room where transactions wait to be confirmed by miners. The attackers set up automated bots to watch the mempool for any rescue attempt coming from a compromised cold card address. Here, the bot instantly copies the victim's transaction, changes the destination to the hacker's wallet, and attaches a higher fee. Since miners prioritize the highest bidder, victims were trapped in a bidding war, forced to outpay hackers in real time just to move their money. A human cannot outclick a bot that sees every move before it is finalized. The public network had become a trap. The only solution was bypassing the public mempool and sending rescue transactions directly to a private mining pool, like the industrial server farm shown here. Because the hackers couldn't see these private transactions, they couldn't copy or outbid them. The coins were moved and confirmed before the bots ever knew they were in flight. A single coding error broke the math of decentralization. To save their assets, the most dedicated crypto purists had to abandon their core philosophy and put their faith back into a centralized authority.